Hello, my warriors. And today's session is going to be a very interesting one for all the NEET students who want to crack the NEET exam this year or even next year. A very important chapter of dual nature, just like the movie Aparajit. And if you have seen this movie, you know how the hero has two split personalities. And then the same thing happens with light too. Light sometimes is like, hey, I have momentum, I'm a particle. And then light is next moment like, okay, I can bend, I can spread, so I'm a wave. And then light is like, hey, guess what? I have, energy, and I have, radiation pressure. I can hit something, I can apply pressure. And the next moment light is like, okay, I can also interfere with each other and I can also create constructive, destructive interference. So light has this very amazing dual split personality, and that's this hero who was trying to tell you at that point of time that Shreyas sir is going to teach you this chapter in one shot. So that's the promotion of this series, Zero to Superhero. He's a hero, of course, actually a superhero. And he's telling you, guys are going to get this in one shot. All right. So I hope we are going to complete this in today's class. Hello, Nani, Vandana, Parthi. Hello, Neat Spot. Welcome, Anthony. Welcome, Dalijan. Yes, it's Onion. I know. And how many of you have seen Onion? Yeah, raise your hands. Is this coming in term 2? Yes, it is coming in term 2. Definitely. Neelarjanan. Hello. Good evening. So, those of you who do not know me, my name is Onion. Oh, sorry. Not that Onion. My name is Shreyas. And I'm the physics master teacher. And I have been, doing lots of things. You can read it out here. Blah, 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 blah. And you can also follow me on Instagram. Okay, cool. So, let's get started. And yes, we are going to see a lot of things today: dual nature, photons, properties, photoelectric effect, Thomson's Rutherford model, Bohr's model, hydrogen spectrum. All of this in today's one shot, just like Onion said. Yes, Sundar. Oh my God, my secret is out. Okay, it's not a secret actually. Onion. Actually, the spelling of onion is not O-N, that Kanda. No, it's something else. I think. A-N-I-Y-A-N. Okay. Cool. Dual means, Ankit, this is dual. See, this is dual. This, you are this, and then that's dual. This is one. Okay, so that's one, and what you see behind that one, that's dual. You have some personality this side, some personality the other side. So that's dual. You have a dual personality disorder. So that's what it is. All right. Cool. So, in the first part of this session, let's talk about the dual nature of light. Like I just told you, light sometimes shows particle-like behavior, as in it shows properties like momentum, force, just like when you throw a ball on somebody's face. Have you thrown a ball on somebody? Please don't do that. Okay, so obviously you will get hurt. It has some momentum, it will exert some force. And if you throw balls, through an opening, the ball will pass through the opening without getting deflected straight ahead of that opening. It won't bend, just like Rajnikant does when he shoots bullets from his gun. The bullets bend. That's weird because the bullets are particle, but that's Rajnikant again, so that's an exception. And it also shows properties like interference. It also shows properties like diffraction, refraction. All these are the properties of waves. So we have associated dual nature for light. It's like, okay, you exist together, no problem. We have no issues whatsoever. Yep. Is this complete section? Yes, Rebecca, definitely. Good evening, Chandra Lekha. Wow, I like your names, guys. Amazing names. Neelarjan, such powerful names. Anurag, Joseph, Samrat. Look at the name. Mansa Reddy. My God, Chandra Lekha, Vandana, ALW. Crazy. Anthony Gerard, Vignesh Rasuri. Amazing names you guys have. Proud of you. Okay, so according to Einstein, the particle nature of light, what is it called? Photon. Photon. Okay. So a photon is like a packet of energy which carries energy, and these packets travel very fast at the speed of light, and these packets, when they hit something, when they interact with other matter, they transfer their momentum to that particle. They create an impact, they create an impulse. Okay, and each packet, like I told you, it has photon, which is called as a photon, has some energy. I'll give you that energy formula and all the important details about the photon. These are the most important properties which you should know, from the theory point of view for board exams, also from NEET point of view. So photon always travels at 3 lakh kilometers per second, or 3 into 10 to the power 8 meters per second in vacuum, and it doesn't matter how you see the photon. So that's very weird, but it's true that no matter how fast you travel, you will always find the photon traveling at 3 lakh kilometers per second. Okay, now the energy of the photon is given by this formula. I'll just put it up right over here. The energy is given by, the energy of your photon is given by h into f, but we all know the speed of light is frequency into the wavelength. So frequency can be replaced by c by lambda. So you can also write it as hc divided by lambda. This works. All right, very good. The week quiz will start in a minute. Just hold on for some time. Yes, and the photon is the energy particle, so it has no meaning at rest. The rest mass is 0. So when you see a photon at rest, that means something impossible has happened. You can never see the photon at rest because the photon always travels at 3 lakh kilometers per second. Even if you travel very fast, photon will appear to travel even faster. So, it's always constant. So you can never see the rest mass, but it has been assumed to be 0. So a lot of people think, sir, the mass is 0, sir. Then the momentum will also be 0. That's the funny part about photon. This is a very fascinating chapter. You think this should not happen, but that will happen. You think that should not happen, that will happen. So mass is 0, but it still has momentum. Photons are neutral and stable. They won't decompose. They won't combine together to form new things like atoms do, like they split or they combine to form molecules. And they do not get deflected by electric or magnetic fields, which is obvious because it does not have a charge. Now, the rest mass is 0, but it has momentum. And what is the momentum of a photon? The momentum is h by lambda. That's very, very important. You should know this. And if you take this P and substitute it over here, you can see h by lambda is right over here, right? H by lambda is right over here. You can definitely write it in terms of momentum as well. Yep, momentum is E by C. You can substitute all these things, up to you. Yes, expectation and reality not equal to. Can I start class 12 with modern physics? Not a good or a great idea, Aisha. You should start it probably with other chapters. Okay, but yes, if you are in NEET 2022 or JEE 2022, yes, you can start. But if you are 11th to 12th moving, then don't start. Okay, great. Now, there is another concept which is called as the radiation pressure or the radiation force. So when light falls on your face or when light hits something, it applies a force. That force is small, but it is still there. And we can find that force out depending on whether the object or the surface on which it is falling is an absorber or whether it is a reflector. So if light falls on a surface which is absorbing in nature, it falls and it gets absorbed, then the change in the momentum is final momentum minus initial momentum. That's it. And you can calculate this momentum, okay, magnitude wise. You all know it is nothing but, h divided by lambda. That's it. It's nothing but h divided by lambda. That's the wavelength of this light. But if the surface is reflective in nature, it will change its momentum in the opposite direction. In that case, the final momentum change or the momentum change will be final momentum minus initial momentum. So magnitude wise, you are going to see that the final momentum is exactly negative of initial momentum. So that's the reason why you will have minus pi minus pi, but you're taking the mod, so it will be basically 2 times the initial momentum or 2 times of h by lambda. Is that right? Everybody got it? Yes. Excellent. Very, very important. Now also I'll give you one more important formula which you should know. If light is falling on a surface and it has an intensity of I. What is the meaning of intensity? Intensity means how many watts of energy is falling per unit area. How much is the energy which is falling per unit time, per unit area. That is intensity. If the intensity is given, then on any surface which has some area A, the pressure which is also called as the radiation pressure is given by I by C. I by C, intensity by speed of light, and the force, because force is pressure into area, it will be nothing but I by C, the whole into A. So the force on that surface will be IA by C, and the pressure obviously will be I by C. This is if it is absorbing. This is if it is absorbing. Okay, if it is absorbing. If it is reflecting, what will you do, guys? What will you do? What will you do? Come on, quickly tell me. You should be able to tell me this. What will you do if it is reflecting in nature? What will you do if it is reflecting in nature? This is absorbing, so that's why it is IA by C. But what will you do if it is reflecting in nature? If it is reflecting in nature, you are just going to multiply it by 2. That's all. That's the change. Yeah. 2I by C. Perfecto. Great. Now, let's move ahead. And here comes another interesting hypothesis given by de Broglie. So, light shows wave and particle. Wave is when it goes and interferes. Young's double slit experiment. Particle, that's the photon nature, which it has momentum, force, pressure, all of those things. Even matter, like us, electrons, protons, they also have dual nature. Usually your particles around you show particle behavior. Your bottle shows particle behavior, but in a very microscopic level, at a very quantum level, when you zoom in, things look very different and it can show wave-like properties. So, for a particle of mass m moving with momentum, okay, p, the matter wave is the wave associated with a particle, not with a photon. It is not an electromagnetic wave. It is not a sound wave. It is not a wave on a string. It's not an earthquake. It's a different kind of wave which is not possible for you to visualize or see through your naked eye. The matter waves wavelength, which is also called as the de Broglie wavelength, is given by h by p. If you notice, this formula is very much similar to the previous formula. I'll show you over here. P is h by lambda. Just shift lambda there, put p down. You will get the de Broglie wavelength for a matter wave. That's it. As simple as that. Yes, you would have learned this in chemistry. Very good. Excellent. Yep. Now, once you know this, you can also substitute momentum as terms of energy like this. The kinetic energy of a particle, k, will be half m velocity square, which is also the momentum square by 2m. You can substitute momentum as mv, you will get the same expression as before. Hence, from this, momentum will become 2mk, but that's the square of the momentum, so momentum will be the root of this. You can even substitute it over there. And this will be nothing but h by root of 2mk. This is only for particles, okay, of matter, mass, something which has mass, like electron, proton, bottle, pen, my hand, you, watch, air, everything. So that's when you will use this formula. But when you are talking about light or electromagnetic waves, then this is the energy formula you will use, or this is the momentum formula that you will use. Are you getting the difference? Light is an electromagnetic wave. Electric field, magnetic field, completely different. The particle nature of light is called as photon. Whereas the general particles around you, electrons, protons, neutrons, they have a mass m, kinetic energy k, and their matter wave, which is completely a new kind of a wave, like sound wave, wave on a string, that is having a wavelength of h by p. P is the momentum of that particle. Completely different. Okay, time to join the week quiz using the code 224283. It should be also pinned in your chat box. I have also shared it on the Telegram channel. And another way is going to the description box and then joining it using the link. And another way is just going to vedantu.com/weekquiz and entering this code. That's it. Either ways you will be able to do it. Yes, Srikar, I will do it. Okay, so come on guys, start joining the class right away, and I'll be starting the week quiz in no time. Okay, so go to www.weekquiz.in and use the code 224283, or you can directly click the link which is there in the chat box and then you can start. Alright, come on guys, waiting for all of you to join. Go ahead and start joining the week quiz right away because it's going to be fun. And throughout the session we are going to have week quiz after every theory concept that I'm going to teach. Hopefully the week quiz works today. No, Ankit, there is more theory because there are more topics as well. Come on, I'm going to start the first question. Usually you will get 45 seconds. Some questions towards the end will have around 60 seconds. Alright, are you guys battle ready? Okay, are you guys battle ready? Okay, come on, my warriors, join in. This is Kavya for 12th standard students, but if you are 11th standard student, you can still join it because you would have definitely studied this in chemistry. Definitely. Hello, Hari Krishna, welcome. Hi, Janvi. Hello, Rama. Hello, Reshma. Hello. Welcome. Come on, join in, Ankit. Join in, Srikar. Come on. All right, 1 minute. I'm going to start. Within 1 minute, I'm going to start. All right. So get up. We have decent number of people and I'm going to start any moment. Oh, by the way, let me also tell you, even if you're watching this session recorded, you can still join the week quiz. Although you might not come in the leaderboard, but you will still get points and you can compare yourself with the students who participated live. That's a very cool feature of week quiz, and that's how you can even participate in all the class quizzes even after the live class is over. But yes, the fun of a live class is completely different. All your attention on the screen. I'm starting the quiz in 3, 2, 1, go. Here is the first question on your screen now. Yep, I've started. Can be Harshini, this is a NEET channel plus JEE channel. Yes, you can definitely use Harshini for NEET. Exactly, this is for NEET. Please read the description box, guys. Yeah. When a high energy UV photon beam enters the electric field, it will be. Come on, this is an easy peasy lemon squeezy question. Accelerated, retarded, undeflected, none of these. Okay, make sure you write or post or answers only in the week quiz, nowhere else. So come on, an introductory warm-up question for all of you just to brush up your concepts. Today's lecture is all about concept revision and formula applications. Okay, Ara not here. You have to go to weekquiz, betcha. Weekquiz.in, Ara Vindan. Go to weekquiz.in and enter the code and participate there. Malik, Moni, go to weekquiz, not here. Okay, time is running out in hardly 10 seconds. Divya, not here, bacha, not here. Go to weekquiz, participate there. That's the fun. There is no fun here. All right, so let's have a look. I would request the admin to block the students who are going to put the answers over here. Okay, so accelerated, wow. Undeflected, thank God. Yep, that's the answer, guys. How will it be? Okay, let's see the result. Okay, so look at this, guys. So many of you answered it wrong. Why will it be accelerated? A photon is a chargeless particle, and when you pass it through electric or magnetic field, it has no effect on it because there is no charge, there is no north pole or south pole. So hence, there will be no change in its velocity. Good evening, Alpha. Okay, so let's have a look at the leaderboard. Who is this? Anuraj, Rosh and Dalijan. Very good Janvi, very good Joel, Dhruv, Srilata, Priyanka, Yuvadeep and Pariti. Excellent. Moving on to the next question. Get ready on your screen now. Question number 2. Let's see how many of you can answer this. A radiation of energy E falls normally on a perfectly absorbing surface. The momentum transferred to the surface is which of the following options? Okay, come on my warriors, figure this out. If energy falling, if the radiation of energy E is falling on a perfectly absorbing surface, then the momentum transferred is E by C, 2E by C, EC, E by 2C. Interesting. Yes, Alpha, you can definitely join in. There is nothing that you have lost. Okay, join in. Go ahead and participate. You will have fun, even if you are watching the video right now. Is it E by C? Is it 2E by C? Is it EC or E by 2C? Okay. Let's see how many of you can answer this question. 20 more seconds. This is straightforward, direct. Come on, I want you to fight it out, but the catch is who will answer it very quickly. All right. And the time is going to be up in 5, 4, 3, 2, 1 and showdown, I guess. Yes, some more theory. Yes, Ankit, a lot of theory to come. Yes, definitely, definitely. Let's have a look at the results. And this is how our students have answered. Some of you answered E by 2C, E by EC also, 2E by C also, and E by C. Oh, okay. Perfectly absorbing surface, the momentum transferred. Actually, it should be A, not B. This is wrong. This should be correct. Oops, sorry guys. I think somebody who made the quiz gave a wrong answer over here. It should have been E by C. If it was 2E by C, it should be reflecting surface. So I'm not going to show the leaderboard. Let's just skip to the next question. It should be E by C. E by C. Okay. I mean, if you look at it this way also, look at it this way, that the perfectly absorbing surface, then the momentum transferred. So if it is getting absorbed, then the change is only P. But if it is getting reflected, then the change in momentum will be 2P. So the 2 factor comes only in case of reflecting. Yes. Okay. So let's just move ahead to the next question coming up on your screen. I'm not going to show the leaderboard. Question 3 on your screen now. Okay. So Sri Harshit, you got Ekalavya. Proud of you. Make the best use of it and you're going to rock it. Hope to see you soon during the victory celebration when you crack JEE Advanced. Okay. If the kinetic energy of an electron is made 4 times, then the de Broglie wavelength will. Come on, come on, come on, come on. Okay, come on. Let's see how many of you can get this. Okay, come on, come on, come on, guys. Let's see how many of you can get this. What is this? Oh my God. Hari, what do you mean by that, man? The kinetic energy of an electron is made 4 times, then what do you think is the de Broglie wavelength? What do you think is the de Broglie wavelength going to be? Come on. Come on. No, 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 don't answer over here. Don't answer over here. Try to answer in the week quiz itself. I wanted you to participate in the week quiz to get a feel of your mock tests or your actual examinations. All right, let's have a look. How many of you got the correct answer? Wow, very good, very good, very good, very good. See guys, what happens is if the kinetic energy of an electron is made 4 times, then what will happen to the wavelength? De Broglie wavelength is your energy, okay? I'll just put it like this. De Broglie wavelength is h by p and your momentum is root of 2mk, isn't it? Root of 2mk. I just gave you that formula. If you notice over here, this kinetic energy will become 4 times, but it is under the root. So root of 4 is 2 and it is in the denominator. So hence this wavelength will become 1 by 2 times. And 1 by 2 times means it will decrease by 2 times. That's it. That's all you have to think about. Okay, just use the formula. That's it. All right, let's have a look at the leaderboard now and see what's the scores looking like. And then we'll go to the theory part. Wow, we have Abu Raj still at the top, 2939 points. Joel, Janvi, Anthony, Srilata, Ankit, Harish, Abhinash, Rosh and Kavya. Very good, bacha log. I will not show you the next question because the next question will come after some time, because we have to go with the theory part now. All right. So let's go to the theory of the next topic, and that is the photoelectric effect. See, we just talked about how light can behave both like a wave as well as particle, and normal matter can also show wave-like characteristics, whose formula is given by de Broglie. Now, based on the concept of photons, the photoelectric effect can be explained. Photoelectric effect is nothing but when light of sufficiently high energy falls on a surface, then electrons are ejected out, and if the electrons are collected and you connect it across a circuit, you will see a current which is established in the circuit. You will see a current which is established in the circuit. This phenomena where electrons get ejected out because of high energy light, that is called as photoelectric effect. Okay? The electrons which are ejected out, they are called as photoelectrons. Photo means light. So electrons ejected because of light are called as photoelectrons. Number 2. Number 3. Because the electrons go to the other side and they will start moving around in the circuit, so there is a current. That current is because of light again, hence what will it be called? Photo current. As simple as that. I hope this is clear. Yes, I do remember Rohit Kolte. Yes, definitely. Now, ejected means it is thrown out. It has been ejected. Like you would have seen some movies or maybe some documentary where there is a pilot, and because of some malfunction in the plane, the pilot ejects out of the plane. He's thrown out of the plane, okay, by himself. So that is what is ejection basically. Okay. Now, what happens is we need to understand the different parameters related to frequency, intensity. Is there a relationship with the current, and can I somehow increase the current by connecting a battery or reversing the polarities? Also, what will be happening if I change the plate over here? Will there be any effect on the current or other things? This plate is usually metallic in nature, because what is the speciality of metals? They have free, easily ejectable electrons. Things like plastic or wood, they have electrons, but it is very difficult to knock the electrons out. So usually you will use a metallic surface where you have easily removable electrons, so that a photocurrent can be established. Great. Next, so let's talk about all the important aspects about photoelectric effect one by one. So you should remember this setup always. You will always see the light will be falling on one side, photoelectrons will be ejected from that side, and they will be collected and they will be establishing a current in the circuit, because if the electrons go like this, then actually the current will be going the other way around. Just keep this diagram in mind. We are going to solve a lot of problems. Now, why should the light be of a sufficient wavelength or a certain energy? Okay, see, whenever there is a free electron inside the metallic surface, it's not truly free. It's not exactly free in the sense you do not need any energy to take it away. You need to pay some tax. You need to pay some commission to take out that electron, because that electron is still slightly bound to the atom inside that metallic surface. So if you notice, these are different colors of light, and you would notice this is red, this is green, this is violet, and in red color light, when it is falling on the surface, there is no electron which is coming out, but in green, yes, you have. In violet or blue, you have some electrons coming out. What is the reason for this? Red has a very less frequency or large wavelength, hence the energy is less. The energy of photon is less. But in the case of green photon, the energy is more. In case of violet, the energy is even higher. So, therefore, you would now realize that there is a critical frequency for which the photoelectric effect will occur. After that, below that frequency, you will not see the photoelectric effect occur, because the photons do not possess that energy to knock that electron out. Okay, it does not have sufficient energy to knock that electron out. Okay, so that energy, okay, that energy which is required, or that frequency which is required to knock that electron out, is called as the threshold frequency. What is it called? It is called as the threshold frequency, because that is the frequency only after that you will see photoelectric effect which will occur. That is generally denoted by the symbol F0, and photoelectric effect occurs if F more than F0. If F is less than F0, it will definitely not occur. Now, what is the relationship of this frequency with some other parameters of the entire photoelectric setup? How do you think this F0 is decided? What is that thing which affects F0? Who decides the value of F0? Can you guess? Can you guess? Think about it. Critical means that's the minimum frequency after which the effect will occur. Remember, the energy of a photon is HF. Blue light, violet light has very small wavelength, high frequency, so more energy. Red light, large wavelength, like you can see, so less energy because less frequency. So that's the reason why I said more the energy of the photon, the better the chances is for the effect to occur, and the minimum critical, that's the limiting, he's in the critical stage, meaning you do not know what is happening. Okay, what can happen? So after that only you can decide, okay, if effect is going to occur or if the photoelectric effect is not going to occur. Yes, I hope Grishma, Janvi, all of you have understood it. Kavya, everyone. Hello Mahesh, welcome. Yep. Is this clear? Yes, I'm going to come to photoelectric equation also. Now, that critical frequency, the frequency required to throw out that electron depends, or that critical frequency required to start that effect depends completely on this metal. See, imagine you are holding something which you like. What do you like, guys? Maybe you like ice cream, maybe you like chocolate. You are the atom. You like your toy, maybe a teddy bear or maybe a chocolate. You're holding on to it. Okay, I'm just going to imagine, I love this bottle, or I love what is in it. Maybe it has some very nice mango juice or lime juice. I don't know, whatever. I'm going to hold on to it. Somebody comes with very high energy and he knocks me out and he takes it away. He takes it away. If that somebody coming from that side has very little energy, then I will not give it to him. If he comes from that side and he tries to take it, I will hold on to it. If somebody with very high energy comes, there's a very good chance he can knock it out and take it from me, snatch it from me. Now imagine I am little bit stronger or I am little bit weaker. If I'm weak, I hardly have a grip on this like this. Then the person comes from that side, he will snatch it away very easily. So the minimum energy required for snatching that or ejecting that electron depends on the metallic surface. Understood, guys? Somebody saying laptop. Hi Agadish. Very good, very good. Excellent. Nature of the metal. So this F0 depends completely on the metal surface. And that minimum energy required, that minimum or critical energy required, what is that minimum or critical energy required called? That is called as your work function. What is it called? It is called as your work function, and that will be equal to HF0, which is the energy of the photon, obviously. That energy of the photon which is needed to just throw out that electron is called as the work function. Very good. All right, moving on. This work function, like I told you, it depends from a metal to the next metal. Like gold might have different work function, aluminum might have different work function. There's a minimum quantity of energy required to remove an electron, okay, to completely eject out that electron. Okay, I hope all these definitions are very, very clear. Excellent. Now, let's talk about the next part, and that will come over here. Here right now there was no battery, but imagine there is a battery. Okay, let's try to understand. See, these electrons which are ejected, the electrons go like this and follow this path. That means the current which is established in the circuit will be exactly in the opposite direction. This is how the current is established. This is how the current will flow in the circuit. If somehow you place a battery and you push the current or you help the current, more current will flow. Like for example, if you place positive terminal here, negative terminal here, what will the positive terminal do, guys? What will the positive terminal do? It will pull more electrons. It will happily pull more electrons. That will increase the current. More current will flow, obviously. But if you connect the battery to oppose the current, if you connect the battery in the opposite manner, then the current will decrease. And that's what I want you to see in the next GIF and animation. Observe this. Observe this. Look at this. In this situation, the light is falling, electrons are ejected, and slowly you are changing the current. Slowly you are changing the current. And how are you changing the current? By increasing the voltage. Look at this, 1 volt, 2 volt, 3 volt. So when you increase the voltage, what happens is that the positive terminal is connected here. Positive will pull more and more electrons. So the current will increase naturally. It will increase. Yes. Work function is energy Gokul. Threshold frequency is Hertz frequency. Phi is HF naught. And they both are related. More frequency, threshold frequency, more work function. But one is energy, one is frequency. Units are different. They are two different physical quantities, Gokul. I hope this is clear. Next important thing that you should realize, that if you reverse it, like over here, you can see that when you increase the reverse voltage, the electrons which are ejected out feel resistance to reach here, because now the negative terminal is connected here. Negative repels. So you will see the electrons which are reaching now face a lot of difficulty, and there could be a potential for which the electrons are no longer able to reach here. A potential, or there is a voltage for which when you increase the voltage, after that there is no further reaching of electrons to the other side. That reverse voltage for which you stop the flow of electrons is called as the stopping potential. Electrons are ejected out, okay, electrons are ejected out, and you are like, stop it, you're stopping it by creating reverse voltage. So that minimum voltage for which the electrons stop is called as the stopping voltage or stopping potential. I hope this is clear. And that minimum energy, minimum to stop the photo electrons. We all know that the voltage difference applied to a charge causes acceleration or deceleration. Here it is causing deceleration. So voltage difference of V volts to a charge of the electron, which is E, causes an energy difference of how much? Charge into voltage. Remember this formula. This is standard. This is in electrostatics. The energy due to acceleration or deceleration is nothing but the charge into potential difference. Do you know this formula? In case you have forgotten, now remember it. Energy difference is charge into voltage. So that minimum energy which is required to stop it, so you have changed the energy of that electron. So that energy required to decelerate it will be the charge of the electron into the potential difference, which is Vs. This Vs is your stopping potential or stopping voltage difference. Is that clear? Yep. It's something like a capacitor, but in capacitor the electrons don't move between the plates. They move from the outside part. Here the electrons are moving between the plates. in that empty space. EMI for this part? No. Yep. Yes, it could be. It could be mixed with magnetism as well. Yep. All right. So Beast Saver I'm teaching in the 12th standard batch, 11th to 12th moving batch, also in the crash course, which is for the 2022 students. Okay, fair enough. Now let's come to the main part, which is the Einstein's equation. Einstein's equation. A lot of people get confused, sir. I don't remember, sir. How to remember? Please help me. I will help you out. You make it like a story. I just told you. What do you love, guys? It could be laptop, it could be Dairy Milk Silk, it could be bottle, it could be teddy bear, it could be anything. Okay? You're holding on to it. Some person comes with lot of energy, snatches it away. When you are resisting, you are sucking away some energy from him because he's going to knock you out and you are going to resist. He might come with a lot of energy, but while resisting, he will lose some energy because you are going to make an effort to not lose it. But anyways, he snatches it and the precious thing goes away. So he will have little, he just took away this bottle. Now this bottle will fly off, okay, but it will have some lesser energy. Same thing happens here. Look at this now. Look at this. Light is falling on an atom of the metallic surface. It knocks out that electron and the rest of the energy is used as kinetic energy. So what happens is that the energy of the photon goes in, knocking or basically ejecting it out, and the rest of the energy is the kinetic energy of the electron which has been ejected. So what is the energy of the photon, guys? It is HF, isn't it? It is HF. What is the energy required to knock it out or eject it? It is the work function. And what is the kinetic energy of the electron? Well, I'll just put it as KE. That's it. So this is your basic, or the most elementary level of writing the Einstein's photoelectric equation. The photon's energy goes in ejecting it and the remaining goes as kinetic energy. Now I just told you the formula for phi. Don't forget it. What was the formula for phi? It was nothing but HF naught, isn't it? Work function, the minimum energy required happens at the threshold frequency, minimum frequency, that is HF naught. Okay, is the energy. Now kinetic energy. How do you measure the kinetic energy of the electrons? The kinetic energy is measured by this formula, EVS. EVS is the energy required to stop it. That's the least energy you require to stop it. After that, you will never see the photoelectric effect because it will not come to the other side. You will not see current, You will not see current into that circuit. So you're absorbing all the kinetic energy of the electrons. It came with full josh. And then you stopped it and it went back. So you're absorbing that kinetic energy. Hence, the kinetic, this whole thing measures, okay, the kinetic energy of the electron, and hence I can just write this as E into Vs. This becomes your more advanced version of writing the same equation. I hope this is clear. No, crash course lectures, are still available for you to view it as a recording in case you had joined before. But if you are planning to join now, then you can still join and watch all the lectures. You can also give the test at your free time. Okay, so both the equations are very, very important. Is that clear? Can we move ahead to some more questions? Also notice one more thing. Intensity has no role to play in all of this, except for the fact that if the light is more intense, if the light is intense, then there are more photons. If there are more photons, what does it mean? More photons will eject more electrons. So there will be more photoelectrons. If there are more photoelectrons, what will happen? The current in the circuit will also increase. Keep this in mind. Very good. Okay, great. No, Jayant, I do not teach good in crash course. I teach very bad. I teach only good in some places. Why will I teach good in crash course? What is there? No, obviously I don't teach. Okay, so let's go ahead to the next quiz coming up on your screen. So what is Ke max equal to? Aishwarya, Ke max is exactly this. The max kinetic energy of the electron, you have absorbed it. Why max kinetic energy? Why all electrons have different kinetic energy? Because they will have trouble getting out. Some electrons will have lot of trouble to get out of this plate. Some electrons will have less trouble. The electrons which have less trouble getting out, they will have more kinetic energy. So stopping them will be more difficult. Understood? If an electron has less difficulty to come out, it will come with lot of energy. So you will have more difficulty to stop it. So hence, the maximum kinetic energy is measured by, measuring the stopping voltage. So the last, most luckiest, most energetic electron, if you are able to stop it, then for sure you have stopped every other electron. Okay. And yes, some students were like, sir, what about the graphs? Well, I can show you certain graphs like this one, very important graph, like this one over here, the current versus the voltage. And if you look at the current versus the voltage graph, the graph will look something like this. This is your negative stopping voltage. This is 0 volts. This is your positive voltages. The current increases and it saturates. It saturates at a point. It saturates. Why? Because after a point, all the electrons are ejected. How many more will you eject? There are only a limited number of electrons, so you can only emit or emit electrons as many as photons are falling onto it. If 10 photons are falling, 10 electrons will eject. So beyond that you cannot increase it. And if you increase the intensity, then what happens? If you increase the intensity, then you will see the graph go up. This is for more intensity, which I just told you. When intensity increases, then the current also proportionately increases. This is for more intense light. This is for more intense light, which is very important. You should know this. Jayant, we teach the same way, or you can say, the teaching style could be different, but we put in our 100%, 200% efforts, both on YouTube. YouTube teaching is different because this is on this big screen, and the kind of interaction we have is different. In crash courses or on the Vedantu platform, we have another teacher to help you out. There are lots of quizzes and there are leaderboards and so many other things that happen apart from assignments and all the tests that happen. So that there is a systematic way things happen. Okay, so the teaching will be, or style will be different, but the content or the teacher energy will be the same. Don't worry about it, bacha. All right, so here comes the next quiz on your screen. Get ready to join now, and let's see if you guys are there. Okay, let me just put it right up on your screen. Okay, I'm starting the next question on your screen. Okay, I'm starting the question on your screen. Get ready. Make sure all your attention is towards V-Quiz. Okay, here it comes on your screen now. All right, so what do we have over here? In photoelectric effect, if the intensity of light is doubled, then the maximum kinetic energy of the photoelectrons will become. Come on, think about it. Think about it. In the photoelectric effect, if the intensity of the light is doubled, then the maximum kinetic energy of the photoelectrons will become how much? Hello, Maha Lakshmi. Welcome. Participate in the quiz. Come on, double, half, 4 times, no change. What is the answer? In the photoelectric effect, if the intensity is doubled, then the maximum kinetic energy of the electrons will become. Hi Isha, welcome. Okay. Will there be 11th class from the start for 10th graders after the boards in this channel? Please let me know. We will have the 11th standard classes, Tarun, but in a very different manner. Okay. Let's see the final answer in 10 seconds. Okay. Come on. 9, 8, 7, 6, 5, 4, 3, 2, and there we go. We have it on your screen. Yep, a lot of you are saying no change. Is it? Yes, guys, there is no change. Reason, if the intensity is doubled, kinetic energy has no effect on it, because when you change the intensity, then the number of photons will increase, but the energy of a photon will never change. Each photon still has same energy, just the number of photons will increase, which will increase the current, but the energy of a photon is still going to be the same. Hence, the kinetic energy will also be same. Just that there are more in number does not mean they will have more kinetic energy. It's just that more electrons will be ejected. That's all. Let's have a look at the leaderboard coming up on your screen now before we go to the next question. Wow, Joel has gone to the top. Proud of you. Then Anbu, Raj, Anthony, Daljan, Janvi, Lok, Vishnu, Manogyana, Priyanka, Srilata and Yuadeep. Very good. Keep fighting, guys. Things can keep changing. Moving on to the next question on your screen now. Get ready. All right. So what do we have next? A photosensitive material would emit electrons if excited by photons beyond a threshold. To overcome the threshold, one would decrease the... Interesting question. Come on, figure this out. To overcome the threshold, one would decrease the what? Think carefully. What would you decrease? Come on, my warriors. Voltage applied, intensity of light, wavelength of light, or frequency. Quiz is not working, Janvi or Yuvashri. It should, bacha. Just go to vquiz.in and just enter that code, or just click on that link. Or was there a time limit for entering it? I don't think so. There is a time limit. You can join in at any point. Let me try it out on my phone, bacha. Okay, let me just try it out. Okay, 1 second. I'm just trying to log in through my phone and see if it works. You need to log in, I think, through your Vedantu ID. Even if you are not a member, you can still become a member by creating a free account. Even if you have a free account, it works, guys. I'm just trying to join in. Meanwhile, I'll show you the results. Oh my God. 1 second, I'm entering the wrong password or email ID. I'll check it out later on. Show the leaderboard. Okay, let's have a look. Guys. For the previous question, what was the previous question? It was all about, the threshold. What if you decrease, then what happens? All right. Or rather, what will you decrease? So Joel is again on the top, Anbu and Janvi again on the top. See, guys, the minimum energy required to start the photoelectric effect is called as a work function, and work function is hf naught. But if you increase the frequency, then only you can start the photoelectric effect. But the question said, what will you decrease? Obviously, you will not decrease frequency. If you decrease frequency, then the photoelectric effect will not happen. In fact, you can write it as hc by lambda. When you decrease lambda, then the frequency increases, then the photoelectric effect can start because the work function has been overcome. So decreasing the wavelength kickstarts the photoelectric effect by increasing its energy. Lambda is in the denominator. Keep this in mind. So the question said, what will you decrease? What will you decrease? Frequency can't be decreased. It will be the wavelength which will be decreased. All right. Moving on to another question coming up on your screen. Now, let's see what it is. The work function of a material is 5.3 electron volt. The stopping potential for a radiation incident is 4.2 volt. What is the energy of a quantum of incident radiation? No problem. Happens, Isha. Okay. Let me meanwhile start to check if I can log in. Come on, guys. I'm able to. I just saw it. I'm able to join in the vquiz, guys. And why the hell did this open up? Oops. Why is this opening? Okay. Yeah, I'm able to join the vquiz, guys. There is no problem. Just check it out once again. Okay, those of you are not, just you need to probably log in through your account. Even if it's a free account, it is fine, guys. Even if it's a free account. All right, so that's the final answers. A lot of you have answered B, whether it is correct or wrong. Well, looks like you guys are correct. All you need to do is just write it down in the photoelectric equation form. The energy of your photon, is the work function plus E into Vs. The work function is literally mentioned over here, 5.3 electron volt. And the stopping potential is also mentioned over here. What is the stopping potential? It is 4.2. 4.2 plus 5.3, isn't it 9.5? Isn't it 9.5 E? So that's the energy of the photon. The energy of the quantum. Quantum means photon. What is the energy of the photon? That's all they have asked. That's it. You got it. That's it. Cool. Shall we move ahead? All right. Let's have a look at the leaderboard. Let's see who is at the top still. And literally, guys, even if you're joining now, you can still participate in the vquiz right now. Just go to vquiz.in and enter this code. Wow, Joel is still maintaining his top lead. Anbu and Anthony on second and third. Lok Vishnu, Janvi, Priyanka, Daljin, Yudip and Ankit Kumar Singh. Very good, guys. I'll go to the next question after the next theory pointers. Okay, let's go to the theory slides now and see what's up in the theory slides. Okay, I think we'll have atomic structure. Yes, we do have atomic structure right away. So in this chapter of atomic structure or atoms, what you will have is the different theories by different scientists. Each one suggested a different model of the atom. Each one had its own limitations and a good thing about that theory. But the model which is fair enough to describe most of the phenomena is the Bohr's model. The first person to talk about, the atomic structure and who gave a decent idea of how the atom looks like was by Thomson, and then Rutherford, and Chadwick then discovered neutrons, and then we had the Bohr's model. So according to Thomson, it was a watermelon. So imagine, at those times, in those days, if you had just told that, the atom is like a watermelon, the seeds inside are basically the electrons, and the red part is the positive charge, and that's how an atom is. Everybody would have clapped hands for you, everybody would hail you as an hero, and your name would be over here instead of Thomson. But that's what he said. But okay, not to discredit him, understand, even though the model looks very simple at those point of times, to come up with that idea is very, very difficult. Now, why did he say that the seeds are like electrons and not the other way around? Is because they knew at that point of time is the electrons which move when you conduct electricity. So that means electrons are freely movable. It is freely movable inside that conductor. So if it is freely movable, it should be easily, you can easily eject it. So that's why he thought they are like small tiny bits which are spread out and you can easily knock them out. That's what he thought. And because an atom is electrically neutral, equal amount of positive and negative charges are there. So that's why atom is electrically neutral. But it failed many of the things. It could not explain how spectral lines come, or it could not even account for the scattering of the alpha particles when you pass it through a thin sheet of metal, which was conducted by Rutherford. So then Rutherford conducted the most famous scattering experiment of alpha particles. And when he passed the alpha particles through a metallic surface, he found that most of the alpha particles were passing undeflected onto the other side. He had placed a detector around it, okay, so he could detect where the alpha particles are striking. Most of them went without any deviation, like you can see right over here. Some of them got deflected by a small amount. That means when the alpha particles are positively charged, remember that. That means if they got deflected slightly, that means they encountered some kind of positive charge somewhere. So the alpha particles which are positively charged encountered small amount of positive charge, that's why they got deflected. A very, very few number got completely rebounded and they struck the photographic plate behind. That means there are very few alpha particles which actually encounter that positive charge of that atom, and that's when they get completely reflected back and they strike behind. That gave him the idea that since all of them are passing undeflected, so atom should be most likely empty, only a small part where the positive charge is concentrated. So that's when he gave this model of an atom where there is a nucleus which is heavy, positively charged, and electrons are revolving around it because of the centripetal force by the electric force of attraction. But even this model could not explain so many things like the spectral lines and the calculations for ionization energy and so many other things. So then after his limitations came the, oh by the way, you should know all these limitations for boards, they can ask you for boards. Then came the Bohr's model of atom. So when Bohr gave the structure of atom, he gave it in a little bit more fancy and detailed manner, and he said electrons, even though they are moving around the orbits, they still can retain their energy only in certain fixed energy levels or fixed orbits. These orbits are so special that even if a charged particle accelerates, it will not radiate energy. There is something called as Maxwell's radiation. I don't want to confuse you too much, but it says that if you take a charged particle and accelerate it, then it will emit radiation and it will die out and it will lose all the energy. But electrons, even though it is charged and even though it is accelerating, it does not lose energy in those special orbits. Those are called as the fixed orbits. And when an electron jumps from low to high, it absorbs energy from a light particle, which is photon. And if an electron jumps from higher energy to lower energy, it emits photons. That's what he said. And those fixed orbits have angular momentum, which is integral multiples of h by 2 pi. Very, very important, this law. It has integral multiples. The angular momentum is in integral multiples of Planck's constant by 2 pi. Very, very important. Okay, I hope this is clear. I hope this is clear. Okay, now remember these postulates from Bohr's point of view. This postulate is important from your competitive exam point of view, and other things are fairly simple, where nucleus is at the center, the electron revolves in orbits which are stationary, and these are such orbits where energy is neither destroyed or created. Only way you can transfer the energy is by absorbing a photon and shifting it to higher energy state, or losing the energy in the form of a photon again. That's what it is. Now, based on these postulates, he was able to estimate the radius, energy, velocity, time period of an electron revolving around a nucleus. And these are the formulas. You don't have to remember it like this. No, please don't remember it like this. In fact, the only thing that you should remember is what it is proportional to. Radius is proportional to n square by z. The velocity is proportional to z by n. And energy is proportional to z square by n square. That is something what you should remember. Okay? And yes, the constant values. What is 0.529? 0.529 is the radius of the first orbit of hydrogen atom. For hydrogen, z is 1, n is 1 for the first orbit. So that is the radius of the first orbit of a hydrogen atom. That's something what you should remember. Then this is the velocity of the first orbit of again hydrogen. If you put z is 1, n is 1, you will get that. And yes, there should be a minus sign over here because energies are always negative. The energies are always negative. Keep this in mind. That's the total energy of the nth orbit. Keep this in mind. All right. Now that you know this, yes, derivation is important for advanced. Yes, Jayant, it is definitely important. No, for mains and NEET, it is not at all important. Okay. Now, if you look at the energy levels right over here, you will get a sense of how the energy levels are arranged. Zero energy is for n is infinity, which makes sense. When you put infinity over here, it becomes so large that the energy becomes small, tending to zero. Meaning, you have freed the electron. Zero energy means it has no longer been attached or associated or bounded with the atom. Zero energy. Okay, so zero energy means it is no longer attached to the atom, it has been freed. Anything which is less, it is bound to the atom. So zero is basically free, and when it is negative, it is basically bound. That's why sometimes it is also called as binding energy. You would have seen that in satellites, gravitation. Keep this in mind. All right. So you can see the spacing of lines is also not uniform because n square is there in the denominator. When n is 1, the energy is minus 13.6 electron volt. When n is 2, it is minus 3.4 volt. And then as you go up and up, the spacing reduces. The gap is very less because there is hardly any difference when you jump from, a very high state to a much higher state. Okay. Why are energies negative? See, negative energy means it is relative to the highest energy, which is when it is free. So imagine I tell you the energy is minus 13.6, okay, electron volt. If it is minus, it is relative to this. If you want to make this electron jump from here to here, you need to supply energy, and the reference is assumed to be 0 at infinity. Just like for gravitation or electrostatics, you say that when the particles are infinitely apart, that's when their energy is 0. That's a reference energy. Like for MGH, you always take some reference, maybe the ground level. So here the reference is infinity, and that's where you have assumed it to be 0. So if you have to supply energy to reach 0, if you need to give energy to reach 0, that means your energy right now must be negative. I hope this is clear. Okay, understood? All right. Let's talk about the last part in this, which is called as your hydrogen spectrum, and you get amazing, lines or spectral lines which come out of, different elements which are like its signature. You also have your own signature, right? You also have your own signature. So even elements have their own unique signature which does not match with any other element. That's called as spectral lines. Now why does it come? Is because when you agitate and when you give energy to the atoms, they start woggling, they start shaking, they hit each other, they transfer the energy, and when they hit each other because of their temperature, they knock out electrons, and these electrons can then shift to higher energy states. So the temperature gives that thermal energy which can then knock out and which can supply energies to the electrons during the collisions. When the electrons go to higher energy states, they will not be happy for a long time. They will want to come back. They're like, why are you sending me up? I want to go down. So they will eventually come down. When they come down, they are going from higher energy state to lower energy state. That's when you will see photons will be emitted. That's when you will see light will be created. Depending on which orbit to which orbit they are jumping, their energy difference goes in creating that photon. So that's why each jump corresponds to a specific energy which also corresponds to a specific frequency of that photon. So that's why you will see some unique lines depending on their jumps from higher energy to lower energy. That's why you see this unique signature out here. Is that clear, my warriors? Is that understood, my warriors? That's very important. And yes, you have your Lyman, yes Ankit, you have your Lyman-Balmer Paschen series depending on the jumps. If you jump from any energy state apart from 1 to n is equal to 1, that's Lyman. If you jump from higher energies to n is equal to 2, you have Balmer. And then if you jump from higher energy to the lower energy, which is 3, then you call it as Paschen series. So these jumps have been classified depending on where their final destination is. Final destination is 1, Lyman, 2, Balmer, 3, Paschen, then bracket, P fund. That's how it is. That's how it is. Clear? Okay. Now I'll just write down few equations. The energy difference between, the states, or basically the orbits goes into the energy of that photon which has been created. So that will be hc by lambda. Now when you solve this further by substituting the formula of energy of the electron in different states, you get this relationship. 1 by lambda is r z square into 1 by n1 square minus 1 by n2 square. Very, very important formula if you want to calculate the wavelength between two jumps. N1 and N2 are your initial and final destinations of the electron between the jumps. R is called as Rydberg's constant. Z is your atomic number. Okay, so that's how it is. Oh, why is it named like this? It's named based on who discovered it. That's all, Ankit. Okay, chalo, let's start with some quiz which is going to come up on your screen, and here it comes. Let's start that quiz. Yep, the question should be up on your screen in 3, 2, 1 now. Get ready. Okay, so here we come with the next question. Bohr's model of atom assumes which of the following? The options will be visible on your screen in a bit. Trainman, sir, if my home state NIT does not have home state OBC quota and I have filled the form in OBC, so will I be allotted general category home state or national? You will be allotted general category home state, Trainman, not national. Obviously, they will always give preference to your home state and then comes national. Is that okay, Trainman? The nucleus is of infinite mass and is at rest. Electron is a quantized orbit, will not radiate energy, and mass of the electron remains constant. All of the above conditions. Guys, this should not be infinite, this should be finite. Okay, this is not infinite, just make it finite. Okay, and is at rest. Okay, and the electrons is in a quantized. Oh, even if you take it as infinite, still it will be okay. I'll tell you why in a bit, because anyways the time is up. Okay, so guys, the correct answer is all of the above. Yes, most of you are correct. Strictly speaking, the nucleus has a finite mass, but even if you make the assumption that it is infinite mass, it works, because I'll tell you why. If the mass of the nucleus is finite, and if the electron goes around it, actually speaking, even the nucleus should go around. Because their center of mass should stay at rest. Remember, when two particles go around each other because of their mutual force of attraction, they always do so around their common center of mass. Now, if you don't want the heavier particle to move, like when the earth goes around the sun, we assume the sun is at rest, but technically sun is not at rest, sun also wobbles around. So we make the assumption that the sun is rest, that means it is very, very heavy. It's very, very heavy, and that will make sure that the center of mass lies on the sun. Same way, if the center of mass of the nucleus and the electron is on the nucleus, then the nucleus will not wobble, it will stay there. So that can only happen if it is infinite, but actually speaking, it should be finite. I hope this is fine. Next, the electrons is in quantized form. Yes, the energies are always fixed, and only in those quantized energy states, it will not radiate energy. Mass of the electron remains constant. Yes, it always remains constant. It never decreases or increases. Perfect. Let's see the leaderboard right now. Okay, great. So we have Joel still on the top, Anthony still leading, Anbu Raj, very good, Priyanka, Vilok, Kaushik, we have a new person, Janvi, Manognya and Dalijan. Wow, we have some new names coming up on the leaderboard. Next question on your screen now. Here it comes. The ratio of radii of the atom assuming Bohr's model is, come on, let's see how many of you can get this. The ratio of the radii of the atom assuming Bohr's model is, it's going to be an interesting one. Okay, here are your options. You can start working it out. You have 1 minute to answer this question. I'll give you a hint. Think about the radius formula. Bacha log. Okay, think. Okay. SSM, you study well, but I am not getting, I study well, but I am getting fear while studying. How to overcome this? SSM, most likely it's the fear which is coming out because you have not practiced enough PYQs. So once you get a strong hold of PYQs, that fear will go away. So start with mock test, start with some more good questions, and slowly start doing the PYQs without seeing the solutions or answer key. You will slowly overcome the fear, bacha. Okay, let's have a look at the final answer in 10 seconds. Ankit, it should be showing. I'm not sure why it is not showing. It should be. Mohan, watch this one shots. Also watch my regular classes. It's there on YouTube also in the 12th standard Pathfinder. It's there. The playlist series is there. Watch the modern physics classes. It will take you 2 to 3 days max. Within 2 to 3 days, you will become an expert. Okay, just do that. Okay, let's have a look at the results. And looks like many of you are wrong. I'll tell you how to do this question. You need to see how many shells are there. Remember, the radius is proportional to n square. Now, if you look at this atom, don't look at the atomic mass number, look at the atomic number, which is 13. So 13 will be nothing but 2, 8 and 3. So there are basically 3 shells. Similarly, when you write for 52, 2, 8, 18, see how many shells will come. I think there will be 5 shells coming out over here. So when you take the ratio of the radii R1 by R2, which will be N1 by N2 whole square, it will be 3 by 5 whole square. So 3 by 5 whole square is 9 by 25. That's the answer. PYQ can be asked in different ways in NEET, bacha. Not directly, they will not repeat, but they can change the values, or just they can change what is given can be asked and what was asked can be given. They can change all these things. All right, so let's have a look at the leaderboard. Some of you are really maintaining your stand. Very good, Joel, Anthony, Anburaj. Excelente. And here comes the final question on your screen now. Here it is. Very good, Anthony. That is very good. How 5 shells, Ankit? Just write the atomic structure of it. KLMN. Ankit, you know, right? 2, 8, 18. Check it out. How many shells will come? You will get 5 shells. Yes, Zenbod. I will be doing one shots for 11th portions also, but first preference for 12th term 2, because that is coming very soon. Okay, cool. So the ground state energy of hydrogen atom is this much. When the electron is in the first excited state for helium, then the excitation energy is. It's for helium, be careful. Is NCERT alone enough for modern physics? Mohan, 90% yes, 10% maybe you might need some help, 10-15% for from HC Verma, okay? Because there could be some questions which require some good level of understanding and concepts, and that I feel you will get it from HC Verma. If you want to score 120 marks or 130 marks in physics, then not needed. But if you are aiming for 120 plus, 140 plus in physics, then you need to study from HC Verma, bacha. Okay. Pathfinder is available for entire timer. It is now called as 12th standard. 12th standard JEE NEET. You will see it. 12th standard JEE NEET. You will see it. Physics, chemistry, maths, everything has been arranged. Alright, let's have a look at the results. The correct answer, oh, very few people got it. I'll tell you what you have missed. This is the energy of hydrogen, but what is asked is helium. They are completely different. And its excitation energy has been asked. So to excite it means you have to make it go from 1 to 2. So the energy difference that we are talking about here is E1 minus E2, modulus of that. So basically it will be 13.6, that's constant value. Z for helium is 2. So you will have Z square, which is 2 square, by 1 square minus Z square by 2 square. This is what you're going to get. Just do the math. 2 square is 4, and here you will get 1. So just do the math, guys. You're going to get the final answer. Z square by n square. Just do the math and you will get the answer. Yep. So it should be Yeah, it's not 3.5, it's helium, it's not hydrogen. Be careful about it. Be careful. Okay, just be a little bit careful about it. All right, let's have a look at the final leaderboard and let's see how many of you got it. NCERT alone enough for modern physics? No. Mohan, like I said, for getting decent marks, yes. Would you get top marks? No. Okay. So it should be working, bacha. If it is not working, then I'll tell you what to do. And yes, we have our winner for today. Joel, very good. Anthony, very good. Yuvadeep, very good. Congratulations, bacha log. You have done fabulous job out here. You got very good marks. Proud of you. I'll just end the quiz right now. So all you need to do is, if you're watching the video right now, and if you're still not able to join the Telegram channel, I'll tell you what you can do. One simple hack, usually which works. So Telegram channel, just click on this. It is not working. Okay. You see this link over here? Over here, that t.me, right? Just replace it with Telegram. Just replace it with Telegram and put that enter button. Now you will be able to join it. That's the only thing or change that you need to do. That's it, guys. All right, perfecto. Let's move to the last thing. Yep. So guys, if you enjoyed the session, make sure you go ahead, join the Telegram channel so that you get all the important updates. Go ahead, hit the like and subscribe button. And yes, all those interested in the crash courses, go check out the link which is there in the description box, because crash courses are available for a very cheap rate of just 1,800 rupees. Go ahead, check it out. All tests, assignments, lectures, recordings, everything is available just for you, both for JEE and NEET. All right. Thank you very much for tuning in, and I hope you guys had a great time. Bye bye. Take care. And yeah, the crash course validity is till the last exam, even if it gets postponed. Don't worry about it. Bye bye. That's it from my side. This was Shreyas here signing off.